quantitative literacy. This video is the first part of 12.5, so this will be 12.5a. We're going to look at the normal curve for section 12.5. This lesson's emphasis is on the empirical rule. But before we get into that, a little bit about the normal curve. The normal curve is basically a curve way of doing a histogram or a bar chart. So it's basically saying if I had done a histogram on some data and I had a little bar, then a little bigger, then a little bigger, a little bigger, and then it started to shrink back down, I can basically in math make a little curve that fits over this somewhat. And if that curve rises to a peak and then falls back down and has a pretty good symmetry on the left and right side, then it's considered normal or close to normal. So normal in stats is a very specific word. It means we have this nice bell-shaped curvature. The mean, median, and mode are all dead center. So wherever this was, now it's not saying it's the number 0. That's how many standard deviations we are. Whatever that number was in the data set, that is the mean, it's also the median, and it's the mode. Now, what the empirical rule says is, if again, this curve is actually representing some little bars, and remember those bars each represent an amount of data values in that group, in that class. The empirical rule says that about 68% of those values are within 1 standard deviation from the middle. So basically it's saying from here to here, that would be 68% of the total data. So the bars that fit in here account for about 68% of all the bars. Well, not of all the bars, of all the numbers of data values. So what that means, and you'll want to add this part to your notes, is that if both of these sides represent 68%, they're both equal, which means each one of them would be 34%. So each one of those is about 34% of the data. If I hop out to 2 standard deviations, that represents 95% of the data. Now let's figure out what we're going to do here, though, to figure out what these little chunks are, this little slice here and this little slice here. I know they're the same, they look the same, but what the heck are they individually? Well, yes, this is 95%, but that 95% includes that 68% that was on the inside. So the first thing I'm gonna have to do is 95% minus 68%. That gives me 27%. So that means this sliver plus this sliver is 27% of the data. Slice that in half, and that means each of these small pieces is 13.5%. I'm going to zoom in because these next parts are going to get even smaller. Now, if I go out 3 standard deviations, now I'm at 99.7%. But that 99.7% includes the 95%, so the same process I just did. If I subtract those off from each other, that gives me, let's see, that's going to be 4.7. So what am I saying? I'm saying this little bit over here and this little bit over here add up to 4.7. If I want to know each one individually is, I divide that by 2. That's going to make this tiny little sliver and this tiny little sliver each 2.35%. And I'm not writing the percentages, symbols on these just because I don't have room. The last thing would be anything outside of that 3 on each tail. Well, all of the data represents 100%. And if I subtract off the 99.7, that leaves me with 0.3%. So this little bit over here, this little bit over here represent 0.3%. If I divide that by 2, each one of these even smaller slivers represents 0.15%. 0.15%. So clearly, a bulk of the data is in the middle between the first 2. A bulk of your data, almost 2/3 of it, well, actually over 2/3 of it, 68% of your data is right in that middle, 1 standard deviation each way out. Then it obviously drops significantly from there. We're going to use these percentages to solve the problems on the remaining parts of this section. So what I like to do is, let me move this, make this a little bigger and covered up some stuff here. There we go. Is I like to always on these problems draw myself a normal curve. I'm going to draw a bell-shaped curve with the information given. So how do we do this? So a normal distribution has a mean of 75, standard deviation of 2. Okay, what does this mean? I'm going to draw myself a bell shape, and they're not going to look great. They are supposed to be symmetric. I'm going to shoot right down the middle. That's the mean, or the median, or mode. It's all the same. So that's going to represent the number 75. And then on each side, I'm going to try to draw 3 evenly spaced lines. 1, 2, 3. 1, 2, 3. And the distance from the middle to each one of these is the standard deviation. So these are all going to be +2, +2, +2. Likewise, going down this way, these are all going to be -2, -2, -2. So the numbers on here, and you don't necessarily have to write those +2s and -2s, but the numbers are going to be 77, 79, 81. So that was adding 2, 81. Over on the other side, it's going to be -2, so 73, -2, 71, -2, 69. I think the easiest thing to do from here is to fill those percentages in. I'm going to zoom in so I can actually write them a little bit better, that we just talked about. So I know 34% is within 1 standard deviation each way for a total of 68. If I go out another one, it's 95%, which we decided meant there was 13.5% of the data in these bands. If I go out another band, it's 2.35%. And all the way out, anything farther out here is 0.15%. And again, this is amount of data. Okay, so now that I have those percentages, I can solve all the questions given here. So find the percentage that lie in the given intervals. So more than 75. So more than 75 would just mean everything here over. Well, there's a couple ways to think of this. You could add up the numbers, 34, 13.5, 2.35, 0.15. If you add those up, go figure, you're going to get 50%. Another way to think of that, though, is that 75 splits it in half. So half of the values are bigger. For letter B, more than 79, well, that's going to be here over. So I'm adding the 2.35 and the 0.15. If I add those together, I get 2.5%. Between 71 and 77, okay? So now I'm doing between 71 and 77. If I add the percentages that go with that, I'm adding the 13.5, the 34, and the 34. If you add those up, you end up with, let's see, 81.5. That's going to be 81.5%. And for the last one, less than 69. So that's just here over. That's only the 0.15. So that one's going to be 0.15%. On number 9, suppose 200 students took an algebra final. The mean was 63 with a standard deviation of 4.5. Oops, need that down there. Okay, again, I'm going to draw the curve. Oops, maybe I'm going to draw it. Let's try that again. There we go. All right, mean is what's dead center, 63. Again, draw 3 somewhat evenly spaced lines on each side. The standard deviation is 4.5. So again, what does that mean? That means I'm going to add 4.5, add 4.5, add 4.5. On the other side, subtract, subtract, subtract. So that's going to give you the following numbers. If I add 4.5, I get 67.5. And actually, for this particular problem, I can kind of stop there because it asks me how many students scored more than 67.5. I don't really need to write the other ones. I know the marker that I need, so I need to figure out what percentage is beyond the 67.5. Using those same percentages that we just looked at, we know that this part is 13.5. The next part is 2.35. And the last part here is 0.15. If I add those together, that is 16%. Now, be careful. It didn't say what percentage of students, it said how many students. So the last step I have to take is I have to figure out what 16% of 200 students is. So 200 times 0.16 will give me 32 students. So assuming this was a perfectly normal distribution, nice bell curve, 32 of the students did better than a 67.5 on the final. Okay, that does it for this first part, 12.5a.